Fresh uranium fuel pellets are made from two isotopes of uranium. Both have half-lives of over 1 billion years, so they're hardly radioactive at all. As they undergo nuclear reactions over a period of a year or so, they get more and more radioactive. When uranium nuclei fission into two smaller nuclei, plus some neutrons, one nucleus is typically a bit bigger than the other. These two smaller nuclei, called fission products, typically have too many neutrons to be stable. So they're beta emitters, achieving stability by changing one or more of their neutrons into protons. Many are gamma emitters too. Most, though not all, tend to have shorter half-lives, from hours up to 100 years or so. As well as splitting in half, a uranium nucleus sometimes absorbs one or more neutrons without splitting. This creates new elements with nuclei bigger than uranium. They're called transuranic elements because they're beyond uranium in the periodic table. They have cool names like plutonium, neptunium and americium. Transuranic elements are all radioactive because their nuclei are too large to be stable, and they're typically alpha emitters. They tend to have long half-lives, from a few decades to millions of years. All these waste atoms, the small nucleus fission products and the big nucleus transuranics, like plutonium, just remain in the fuel pellet. When a fuel pellet comes out of a reactor, about 95% of it is just the same as when it went in, unchanged uranium. The fuel pellets don't look any different, but the short half-life fission products make them highly radioactive. They're ceramic, so are very hard, and dissolve in water at about the same rate as granite. This is the main reason why it's safe to dispose of them deep in the bedrock. The radiation itself only travels a very short distance, and the radioactive material just stays in one place away from people. There's more about the risks of long half-life waste in Lesson 7.